Hello, everyone. You are welcome to today's lesson. And the first part of today's lesson is going to be a very short one. Our main objective will be going through the solution to the assignment that was given in the previous lesson of what? Vectors. Okay, lesson 2 of what? Of vectors. Okay, so just as you can see on your screens, okay, we have the questions here. So we were given two questions. Given that, okay, the vector AB, vector BC with the corresponding, okay, component, vector PQST. Find the values of X and Y. Find the values of X and Y. Okay, if so, this is the condition that you are supposed to use to find, okay, the values of X and Y. Okay, so quickly I'll walk you through the solution, and I also know the major concerns. I'll try as much as possible to address all concerns, especially the major ones. Any outstanding ones, you bring it out, then okay, we'll look at that, okay, later. So now you know, after reading questions, underlining the salient parts, if any, you move on and go and write solution. So the first thing that you write is solution, which some of you didn't write. Okay, so please take me. If you want to write a question, write all the questions before you come and write solution. Don't write question 1, solution, question 2, solution. No. Okay, if you want to write the questions, write all the questions before you provide your solution to all together. Okay, so I guess my point is well made once again. So you extract the given vectors. So you were given 4 vectors. So you extract all of them. And those of you forgot the arrow, or I've told you without the arrow, okay, on top, what you have there ceases to be a vector. It becomes a line segment. So please, it will not be a directed line segment. So please take note. Okay, let this be the last time you, okay, forget to do that. Okay, all right, then after that, okay, so we will need this information to find what the values of X and Y. So once we have that, okay, we know this information here is about equality of vectors, because this side, okay, is a vector, this side is also a vector. So we are equating two vectors. Only that one side is a simple one, the other side is a complex or composite, okay, vector situation. But in any case, you end up getting simple to each side. So what do? You can choose not to write but this must be extracted, your equation that you are going to solve. So indirectly, we are dealing with vector equation. So now what do? After this, after extracting, you come and substitute the corresponding vectors. Let me pick the pointer so that you can, okay, see it seems okay. So after extracting, okay, this one just B1, copy and paste. So this one is low hanging mark, extract low hanging mark, B1, B1. Okay, substitute. When you substitute, corresponding vectors, BC is here, vector ST is here, vector PQ is also here. So at this point, what you are supposed to do, okay, you know that you need to make X and Y what? The subject, sort of. The subject. So I said, based on lesson 2, I said make sure that before you equate, okay, your component, make sure that to each side of your equal to, you have a simple vector. So a vector with the S column and the Y, did I say S column? The S component and the Y component being explicit. Okay, very clear to each side. Take note. So at this point, before you can do that, any vector whose coefficient is not 1 or -1, you have to go and work on it. So here, this vector here, its coefficient is not 1, neither 1 nor -1. So we come and multiply. So it will be half times 8, which will give, did I say half? 1/3 times 8, which will give us 8 on 3. Then -2 times what? 1 on 3, or 1 on 3 times -2, which will give us -2 on 3. Please, okay, I've told you, avoid decimals if possible. So at this point, write the fraction. The fraction will be fine. Okay, so those of you who use the decimals, obviously it's like you didn't heed to a certain advice, but no worries. Okay, maybe today I will be a little lenient, but going forward, if you do that again, I will not, okay, tolerate that. I will not be lenient at all. So this must be that this will be intact, this will be intact, because the coefficient of what each of the two vectors is either +1 or -1. So you are okay. Now what do? We are looking for x and y, but you can see that the vector containing x and y is negative here. Okay, so I decided to move this one to this side and bring this one here. Somebody can choose to keep it here, then later divide through by -1, or can push the negative through so that this becomes plus. So that when you are equating, you equate negative x is equal to something, negative y is equal to something. That's not how I dealt with it. So you can equally adapt. So it's just like you are solving for any variable in a simple equation, not a vector equation. If your variable that you are making the subject is negative, move it to the other side so that you avoid dividing by negative. That's what I usually do, because negative could be stubborn. So I moved this one to this side, then brought this one here. So that will give me 8/3 minus 2 on 3 for my first vector. This comes here and becomes negative, so it will be minus, okay, the whole of this vector, which is what we have here, is equal to, and you bring this one here, which will give us what we have here. Now you can see that you can easily combine these two vectors because they are all in terms of values. So mentally, or if you like, you can use your calculator. You do 8/3 minus 1, so it will be 8/3 plus 1, okay, which will give us 11 on 3. Then the y component will be -2 on 3 minus -5. So -2 on 3 plus what? 5, which will give us 13 on 3. And that's supposed to be x what? Y. Unfortunately, you cannot conclude here. Like I told you, someone asked, and I said no. I think it was Prof. Amma also. Okay, you cannot conclude here. What do? You have to make sure that you equate corresponding components because you are asked to find the x and y. So when you equate, so this implies that if I'm equating, somebody can write 11/3 is equal to x and 13 on 3 is equal to y. But I decided to write my x and y first. So this implies that x is equal to 11 on 3 and y is equal to what? 13 on 3. And that is where most of you ended. Some of you even wrote therefore. You could have concluded here, okay, and there would have been no issue if the fractions here were proper, okay, fraction. But remember, I've told you, avoid concluding with an improper fraction. So there again, low hanging marks. Okay, most of you, okay, give out that or dashed out what that mark. So you come and conclude here. That's when you change your improper fraction to the corresponding mixed numbers, and that will be your conclusion. Take note. Even at this point, somebody could have concluded with taking the mixed, okay, fraction or number fraction of what we have here. So somebody can move from here to here straight away. In that case, the person will get the A2. So this mark here will be given here as well. Only that I'm pleading with you, anytime you are equating, let us see what you are equating before you go and work on what you equated. Okay, I guess my point is well made. Now, question 2. Determine whether or not the vector C, okay, the position vector C with these components and the position vector D with the components here are parallel. So we know that there is a certain condition that two vectors must satisfy before you can say that they are parallel. And what is that condition? So you extract, as you always know, and please, some of you ignore the tildes. So it will come with a penalty. I will tell you very soon when, after walking you through the solution here. So you come and state your condition for two vectors to be parallel. So vector CD to be parallel to vector, did I say vector CD? Vector C, okay, so that to be parallel to vector D. Your vector C should be equal to a scalar multiple of vector D. And here, again, okay, we can see that the bigger vector is this. And I told you that it doesn't even really matter which one you take as your bigger vector or not. Okay, sorry. So at this point, just come and substitute your vectors into the premise. That's your foundation of your argument. So your vector C is equal to K, your vector D. Then you come and write this side. The coefficient is not 1 or -1. So what do? Okay, I know at the normal circumstance, this, okay, your next step should have been 4K. So you can say that I skipped a step because I could do that mentally, which equally you can also skip. At the normal circumstance, it should have been this is equal to -K, okay, then 2K before I will come and equate. Remember I said that is the advice, so go by that. Okay, before you lose certain marks that you are not supposed to lose, meaning you show maturity, okay, which will be costly. So at this point, what do I do? I think later I will put the marks there for you so that those who wrote that will get something there. Then you equate. So I'm going to equate -4 should be equal to what? Minus k. Okay, then -10 and -10 should be equal to 2k. So you come and solve for your k. Here I know most of you will divide by minus what? 1, right? Again, divide. But I will not do that. I will move this one to the side and move this one to the side. I always want to avoid dividing by negative if possible. So if I move this one here, move it, I'll get k to be equal to 4 straight away. Okay, if you divide, you get 4 is equal to what? K. It's the same thing anyway. Then at this point too, I know. Right, again, divide by the coefficient of k, which is 2. And that gives you the k here. So since you have two distinct values, okay, for k, that's supposed to tell us that, okay, the two vectors are not parallel. Because if they are parallel, we should get, okay, two identical values for k. You should get the same values for k. So at this point, what conclusion do you draw? Therefore, the vector c is not parallel. So parallel, you cancel it to the vector d, since the vector c is not equal to the vector what? D. And don't forget the tilde is the tilde that will make it a vector. And let me draw, okay, a particular somebody does this. Please take note. Okay, if you do this is equal to, not equal to will mean cancel it. But somebody did this. Okay, this is not, this is hash. Okay, so if you write this is not the same as this, and I believe you all agree with me. So take note, if that's what you did, it will be minus half. Okay, for your A mark here. And again, if you extracted your C's without what the tildes, it will be minus half. Anywhere you extracted them without the tildes, it will be minus half. So take note. And again, what you have here is an equation. I saw that somebody started with equal to. Immediately you start with equal to, you know you are doomed. I've told you equations, you start introducing your steps with implication, not equal to. So you cancel the equal to there, then you do minus half there. Okay, take note of that. Okay, don't be too worried about this deduction. It's just to draw your attention to the fact that next time I should do everything possible to protect, okay, my marks. I should do the right thing basically. So on this note, okay, this will be the solution to the assignment, and the total marks, okay, will be 15 marks. Okay, so if you had 15 over 15, indicate on top of your first page 15 over 15. So it should always be your score over the total score before you capture your work and send it, okay, to me again. Take note, you are all supposed to submit your marked version. I've taught you how to mark. You now know how to mark, so you should know how to write as well, how to do your presentation. Okay, so thank you very much, okay, for your attention, for your time. Okay, God bless us all.